All right, so 1-6 is called solving other types of equations and then solving polynomial equations. So this is like a mix of polynomials in equation form, but different from what some of them similar to what we've done before. Some of them are a little bit newer. So when we're solving, most of these can be factored. So the first thing you want to look for is, can they be factored? Okay, not all of them, but most of them can be factored. If they weren't factorable, you could use the quadratic formula. If they're factorable, the first thing you want to check for is, can you factor something out? Okay, because it tends to be what we forget. You want to factor something out, but you can't get rid of it. You keep it there on the front of your parentheses, and then that would be one of the factors you set equal to 0. If the variables on the first term, if the variable on the first term is the square of the middle term, you can use substitution to simplify the polynomial. We'll get to the end, and I'll say this is what I was talking about before, and then you'll know what that means. So we start with ones you should already know how to do. Something like number 1, which says 3x to the 4th equals 48x squared. Now on your test, you had one that was like this, but it said x squared and then x. And some of you divided both sides by the x to cancel it out. Remember, you cannot do that, okay? So the goal here would be to get everything to the same side. So I'd get 3x to the 4th minus 48x squared equals 0. Once it's set equal to 0, so you got to do that first, then you want to look to see if you can factor this. So can this be factored? Yeah, what can I factor?
3x squared.
Good, I can factor out a 3x squared. And it doesn't go away, it stays on the front there. So this becomes x squared minus 16 equals 0. Then what? X squared minus 16 is the difference of 2 squares, so I get 3x squared and then x plus 4 and x minus 4. Now it's as factored as it gets, right? So now I want to split and solve it. So I would set this equal to 0, this equal to 0, and this equal to 0. 3x squared equals 0, x plus 4 equals 0, and x minus 4 equals 0. So for the first one, I'm going to divide by 3. I get x squared equals 0, square root both sides. That gets the plus and the minus, but plus and minus 0 is still just 0. Subtract the 4, I get x equals negative 4. Add the 4, I get x equals positive 4. So there are 3 answers here, negative 4, 0, and positive 4. So again, you cannot divide everything by 3x squared and get rid of it, okay? You lost the 0 there, and 0 is a solution to this equation. If I plug 0 in, it works. So you got to make sure you don't cancel it out. All right, so what would you do for 2? Good, take out a 3x squared again. This time I end up with 3x squared minus 4. Can I factor the second set of parentheses? No, it's not the difference 2 squares. It's the difference 1 square is there, but not the other. So now I just go straight into splitting and solving. So I would divide by 3 here. I'd get x squared equals 0, square root, and I get plus and minus the square root of 0, which is just 0. On the right-hand side, I'd have to take 3x, move the 4 over, equals 4, 3x squared. Then divide by 3, x squared equals 4/3, square root, putting that plus and minus in the front. I get x equals plus and minus the square root of 4, which is 2, over square root 3. Can I leave it like that? Nope, you got to do what? Rationalize it. So I multiply by the square root of 3 in both the top and the bottom, and I get plus and minus 2 root 3 over 3. So my solutions are 0 and plus and minus 2 root 3. You can list them out like if it was just an open-ended question, you can list it as plus and minus 2 root 3 over 3 and 0. Okay, I think WebAssign needs you to separate it out. I'll look before we finish, but. Questions on that one? Just don't forget your plus and minus. Okay, then we look at number 3. First of all, it's already said equal to 0, so that step's done for us. Can I factor this? How? By grouping. So I put these, I take out the x squared here, x minus 3. I take out a positive 3, x minus 3. The x minus 3 repeats, and then x squared plus 3 equals 0. Can I factor x squared plus 3? No. So I split and solve, and I get x equals 3. X squared equals negative 3. X equals plus and minus the square root of negative 3, which would be what? Good. Plus and minus I square root 3. All right, what's the first step? Group it. Okay, from the first set of parentheses, you can take out what? X squared, and I get x minus 5. Second set, you can take out? Negative 2. Good, because we need the sign to change. And then the x minus 5 and the x squared minus 2. Split and solve. And I get x equals 5. X squared equals 2. X would equal plus and minus the square root of 2. So on the homework, it'll say, that's what I was just checking. It'll say to write your answers separated by a comma. So you'll just have to do negative root 2, positive root 2, and then 5. The order won't matter, but it does say separated with a comma. So just be careful there. And remember the shortcuts like SQRT, we'll actually do a square root. So if you don't want to use that little like toolbar thing that pops up, and the slash will give you a fraction, like that stuff should start to help you out a little bit more. Okay, so now go to 5. I already said equal to 0, right? What do I have to do?
Divide everything by 3.
Good. So I can actually divide everything by a number as long as I go all the way across, and it's okay to cancel it out. I cannot do that with a variable, but I can do it with a number. So I can divide everything by 3 as long as I go all the way across, okay? Because I'm not eliminating a root. I can't do it with a variable, but I can do it with a number. So I would get 2x to the third minus 9x squared minus 18x equals 0. You don't have to do that, but obviously it makes your numbers smaller. It makes them a little bit easier to work with. Now what? Take out an x. So I also could have taken a 3x and left the 3 on the x at the front. It's not going to change my answer. Now I get 2x squared minus 9x minus 18 equals 0. The x you cannot get rid of because that is an answer. Now what? How do I factor this?
Multiply minus 28 and 2.
So you do the first and last, multiply 8 times negative 18. I'm sorry, 2 times negative 18. I get negative 36. Factors of negative 36 that sum to negative 9 would be what? Good. Positive 3, negative 12. And I get x still on the front. 2x squared plus 3x minus 12x minus 18. Factor that by grouping it. So from here I could take out an x. From here I can take out a negative 6. I get 2x plus 3, x minus 6, and then the positive x that's on the front has to get carried down. Don't forget it. Now I split and solve. So I get 0. 2x would equal negative 3, x would equal negative 3 halves, and x would equal positive 6. Yep.
So if I took out the 3x at the beginning, I could bring it down and repeat.
Yeah, it doesn't matter. Because then it would be 3x equals 0. Divided by 3, it's gone either way. Yep, doesn't change your answer. Questions on that one? All right, 6. We haven't done these in a while. What happens when there's no x on the end, so I can't factor out an x squared, right? What happens when my first term is x to the fourth and the middle term is x squared? It's been too long. The first terms are both x squareds, right? So this would split to be x squared and x squared. That takes care of the middle term being x squared, and it makes the first term x to the fourth. So if the first is x fourth, the second one is x squared, then I factor, just like I normally do, look for factors of the last that sum to the middle. But my first term is x squared instead of x. So what are factors of positive 2 that sum to negative 3? Minus 2 and minus 1. Can I keep going? With which one? Good. You can, or you can continue. You can split and solve there. Either way, as long as you remember to do the plus and minus, it won't matter. This one I cannot factor, so x squared minus 2 gets equal to 0, x minus 1 equals 0, and x plus 1 equals 0. So here I get x squared equals 2, square root both sides of my equation, putting the plus and minus there. X equals plus and minus square root 2. X would equal negative 1, and x would equal positive 1. So negative square root 2, positive square root 2, negative 1, and 1. Questions on that one? Yeah.
On the test or like quiz, is it okay if we just write plus or minus?
Sure. Yep. Just don't forget it, the plus or minus. Okay, you do 7. All right, so just like the one before, my first parentheses, or the first term in each parentheses is going to be x squared. What are the factors of positive 12 that sum to negative 7?
Negative 3.
Good. I can keep going with the 1 on the right, because that's difference 2 squares, so it can be x plus 2, x minus 2. Or you can use that square root property. It doesn't matter. Set them each equal to 0. I'd get 3 equals x squared, x equals plus and minus the square root of 3, and I'd get x equals negative 2 and x equals positive 2. Raise your hand if you got it right. Good. Questions? All right, last one on this slide. So this time, obviously, I've got the x squareds going on, but I also have a term at the front. So you can choose how you do this. Either work with the factors and do trial and error, or you can actually do first and last here. You just have to remember the middle term doesn't have an x on it, it has an x squared. So when I multiply 4 times 9, I get 36. Factors of 36 that sum to negative 7 would be what? Negative 1 and negative 36. So when I replace the middle term, it's negative 1x, or negative x squared, and negative 36x squared, plus 4. So when you're grouping and the middle term is squared, you got to make sure you make those squareds. Now, group it. I could take out an x squared here, and I get 9x squared minus 1. I can take out a negative 4 here, and I get 9x squared minus 1. I get 9x squared minus 1 times x squared minus 4. Now what?
Continue factoring.
Good. They're both different to 2 squares, right? This would be 3x plus 1, 3x minus 1. This would be x plus 2 and x minus 2. Then split and solve. I'd get 3x equals negative 1, x equals negative 1/3, 3x equals positive 1, x equals positive 1/3, x equals negative 2, and x equals positive 2. Sophia.
You can also do it when you do like the grouping, like you put at the beginning, you've done 3x squared, right? Or no?
You mean like to do trial and error? Yes. Instead of the first and last. Yes. Questions? Yep.
I didn't simplify the 9x squared. Like, I didn't make it to the 3x, and I still got the same
Because you added the 1 divided by 9 and did plus or minus square root, totally fine.
Okay.
Yeah, you can either factor those or you can use the square root property. As long as you remember the plus and minus, you'll be fine. Yeah. Okay, now we're bringing back in the rational functions into these. Yay, right? Fractions. How do I get rid of that fraction? Sophia. Good. So what's least common denominator of x and x plus 2? I mean x squared, sorry. X squared, right? So I multiply everything by x squared. I want to get rid of those fractions. 1 times x squared would be x squared. Multiply by x squared here. One of the x's cancel. Plus 3x. Multiply by x squared here. They both cancel, equals negative 2. Now it's much more manageable. Move the 2 to the other side. So x squared plus 3x plus 2 equals 0. And then factor x plus 2, x plus 1, and split and solve. X equals negative 2, x equals negative 1. What do you have to do when there's a variable at the beginning in the denominator? You got to check for your extraneous roots. Good. So if I had 0 at the end here, I could not keep it, right? Because then it would have made this or this 0. So make sure you check for your extraneous roots when your original one has a fraction with a variable in the bottom. Questions on that one? Yeah.
What are the extraneous roots of this?
So x could not be 0. Yeah. Here is what happened on the test, sort of-ish, something like this. That cannot happen. You can't factor out an x here and then set them each equal to negative 2. It doesn't work that way. The only way we split and solve is if it's equal to 0. And the reason is because if I took either one of these terms and I made either one 0, they would all cancel and it would give me 0, right? But it doesn't work that way with any other number but 0. So you cannot split and solve until it is equal to 0. Does that make sense? So you would have to move the 2 first. Be really, really careful. This is a big no, no, no. Don't do that, okay? All right, so now I'm going to show you a different method to doing this. We could do it the way we did and do x squared and x squared, okay? Or you can use what we call substitution. So, you'll want to know this for the next slides. These I would choose. You get to choose. If you're good at the x squared, do it. But if you're not, then you're going to do this. The problem with this one is that, well, I'll keep going and then I'll show you. To do substitution, as long as it's in decreasing degree order, and the second term is the square root of the first one, if I'm doing exponents, I would just divide by 2. Then I can actually take whatever's next to that middle term and substitute a different variable in for it. So I'm going to say that a equals x squared. So where the x squared is, I'm going to replace it with a. And where the x to the 4th is, that would be a squared. Because x squared squared is x to the 4th. So this would be a squared minus 3a plus 2 equals 0. So we're substituting in another variable. You could pick any variable you want other than x because that's confusing. In place of that term. Then I'm going to factor this like I normally would. So this would be a minus 2 and a minus 1. Split and solve it. And I get a equals 2 and a equals 1. But I'm not solving for a, I'm solving for x. So I now take this x squared and plug it back in the place of my a's. And I'd get x squared equals 2 and I'd get x squared equals 1. Square root both sides. And I get x equals negative root 2, positive root 2, negative 1, and positive 1. You will get the same answer as if you factor it with the x squareds in the spots. Honestly, I think that the way we did it the first time is easier for these types, but I'm about to show you something that looks really scary at the beginning, but if you use substitution, it's not so bad. So you get to choose on these, but again, you'll see in the next slide. which looks like that. So it looks ridiculous, but honestly, the first term is really just the second term squared. If I did x to the 1/3 and I squared it, I'd be raising it to the power of 2, right? Which becomes 2/3. It will always happen as long as you're in decreasing degree order. That this is the only way to solve them, so it can't change. That you can take whatever's that middle term. Okay, now I'm going to ignore I'm going to say this x plus 1 to the 1/3 is actually equal to a. So I'm replacing that whole term. So the middle one should be easy. This is minus a minus 2. The first one, if it is the middle one times 2, which it will always be, I can rewrite that as a squared. So I am literally taking that whole parentheses and replacing it. If there was a number on the front, like it was 2 parentheses that, then I would write it as 2a squared. Now this is a lot easier to factor, right? We would split this up. This would be a minus 2 and a plus 1. Set them each equal to 0 and solve, and I get a equals 2 and a equals negative 1. But again, I'm not solving for a, I'm solving for x, right? So this is where this comes back in and replaces. So 2 equals x plus 1 to the 1/3, and x plus 1 to the 1/3 equals negative 1. How do I get rid of an exponent that's 1/3? What would I have to raise it to cancel out 1/3? 3. I'm going to raise both sides to the 3rd power. So 2 to the 3rd is 8. 1/3 and 3 cancel out, and I get x plus 1. Subtract the 1, and I get x equals 7. Do the same thing to the other side. Raise it to the 3rd power. This cancels. X plus 1 equals, what's negative 1 times negative 1 times negative 1? Negative 1. Subtract the 1, and x equals negative 2. Ready to do it again? Okay, look at 12. What am I replacing with a? Again, we're just picking a, but it could be any variable. 2x minus 1 to the 1/3 equals a. You want to make sure it's in order, right? I want to make sure the first one is the 2/3 and the middle one is the 1/3. It is. So this whole thing becomes a squared. This is now plus 2. This whole thing becomes a minus 3. So there was a coefficient on the front of that parentheses. I have to make sure it stays. Factors of negative 3 that sum to positive 2. Good. Split and solve. A equals negative 3. A equals positive 1. And then I need to replace the a with what we took out. So 2x minus 1 to the 1/3 equals negative 3, and 2x minus 1 to the 1/3 equals positive 1. I'm going to raise each side to the 3rd power. Cancels from here. I get 2x minus 1 equals negative 3 times negative 3 times negative 3, or negative 27. Add the 1. Divide by 2. And x equals negative 13. Repeat that whole thing for the other side. 2x minus 1 equals 1 times 1 times 1, which is 1. Add the 1. Divide by 2. So negative 13, positive 1. Questions on that one? Last slides. 13. What could you do? Substitute. That same term is squared on the first one and then raised to the first power in the second one. So this time our substitution is going to be x over x plus 1. So this whole parentheses gets replaced with a. This whole parentheses gets replaced with a minus 6 equals 0. Now what? First and last, so 6 times negative 6 is negative 36. Factors of negative 6 that sum to 5.
9 and -4.
Good. 9, negative 4. 6a squared plus 9a minus 4a minus 6. Factor by grouping. First set of parentheses, take out a 3a. Second set of parentheses, take out a negative 2. The 2a plus 3 repeats. And the 3a minus 2 gets grouped together. Split and solve. 2a equals negative 3, a equals negative 3 halves. 3a equals 2, a equals 2/3. Am I done? No, I gotta set it back equal to the a value. So negative 3 halves equals x over x plus 1, and x over x plus 1 equals 2/3. Now there's a lot of different ways to do this. What do you think is the easiest? Cross multiply. If there's one fraction on either side of the equal sign, cross multiply. So the negative can go with the 3 or with the 2. It doesn't matter. It just can't go with both. Okay, so by habit, I just tend to grab it with the top one, but it doesn't matter. Just can't go with both. So this would be negative 3 times x plus 1 equals 2x. Distribute the negative 3. Add the 3x. Divide by 5. Same thing on the other side. Cross multiply. 3 times x equals 2 times x plus 1. Distribute the 2. Subtract the 2x. And x equals 2. Questions on that one? All right, how about 14? Looks completely different, but what? Is x the square of the square root of x? Yeah, so I could do substitution again. Whatever's in that middle term, make the a. So a equals square root of x. This time, 6x becomes 6a squared because square root of x squared is x. Minus 7a minus 3. First and last here, 6 times negative 3 is negative 18. Factors of negative 18 that sum to negative 7. Good. Negative 9, positive 2. Replace the middle term. And factor by grouping. Take out a 3a, 2a minus 3. The next one, it would just be a 1. You don't have to take anything out. 2a minus 3 and 3a plus 1. Split and solve. 2a equals 3. A equals 3 halves. 3a equals negative 1. A equals negative 1/3. Last step, plug back in what a equaled. So 3 halves equals square root of x, and square root of x equals negative 1/3. How do I get rid of a square root? Good, square both sides. So x would equal 3 squared, which is 9, over 2 squared, which is 4. Square both sides. Negative 1/3 would be a positive 1/9. So think that these are eventually going to be like mixed in together. You've got to look and see first, can I factor it? Always start with that. Can I factor out a greatest common factor? Can I factor by grouping? All those things. To do those, they have to be set equal to 0 first. Then, and don't eliminate any x's. Don't divide anything by x and eliminate. Then you get to the ones that are just look weird. And usually you can do substitution on those. Okay? Always look to see you can look at it either way. Is the first term the square of the middle term, or is the middle term the square root of the first? Doesn't matter how you look at it. Those are both the same. If that's the case, substitute in your A. All right, homework is on WebAssign. You've got, I don't even know, 8 minutes if you want to get started on it. You can also give your brain a break and do it for homework. It's up to you. Okay.